I'm Manugon from Kolkata, India. Currently, I'm registered as a dual degree PhD student at Midsweden University, Sweden, and Technical University of Berlin, Germany. In Planoptima Network, I am ESR 11, and the title of my PhD research project is Augmented Telepresence for Interactive Remote Actions. The aim of augmented telepresence is to present a remote scene in real time in immersive way and with some additional information related to the scene overlaid on top of it. The system can be applied in multiple fields like construction, mining, sea exploration, where it is not safe to work in person. So a worker can operate the machine remotely with precision just like they do it in real life. And we can have additional information related to the scene overlaid on the screen of the worker which is operating the machine. So he can have additional context related to the work that needs to be done. Current methods that we have rely on having multiple cameras for capturing the scene in detail. It requires high bandwidth and computation resources. Also, the normal 360 stereo or panorama is not enough to have full immersive field of view. So for that we need 6 degrees of freedom. That means we can move the head and the body freely, just like we explore the real scene in a real environment. This requires more cameras added to the rig and requires more and more bandwidth. In my project, the aim is to develop an end-to-end solution for augmented telepresence which can provide an immersive view of a remote scene in real time under limited data transmission without losing the depth information about the scene, which is critical in having a reliable system. So this system can be implemented in real applications which require high precision. I have divided my task in 2 phases. First, I will investigate how I can optimize the capturing system, data representation and processing methods to work efficiently, so we can overcome the limitations of the current methods that we have. At second stage, I will test the system by performing a user study to see the effects of using different view augmentations in completing different remote tasks, and will further optimize the whole pipeline for reliable results. To achieve my research goals, I am getting excellent support from Planoptima Marie Curie Network by means of workshop, webinars, training schools, and getting supervision from well-known researchers in field of planoptics. That will help me proceed further in this research field and gain expertise. Thank you.